Forever Center for Theoretical Physics. This is second video on this lecture series, Fourier transform. So in this video I am going to talk about harmonic function. What is harmonic function? Any function which repeat after certain time t is harmonic function. It means fx is equal to fx plus t. This is the definition of harmonic function. And one of the simple harmonic or periodic function is y is equal to a sine omega x plus phi. This is the best example of simplest periodic function, where this function repeat after time interval 2 pi by omega, and here a is the amplitude, frequency is omega, and phase is phi. So after time period 2 pi by omega, this function will repeat itself. If we plug x is equal to x plus 2 pi by omega, then we will get back the same function, a sine omega x plus phi. So after 2 pi by omega time interval, this function will repeat itself. So let us take an example of a mass m attached with some spring, and this is the O, origin O, and there is the spring, and spring is stretched from point O to this position P, and this OP is S. So there is a positive displacement. This is positive x direction, this is negative x direction. So there is a spring due to which the there is a spring force due to which the mass point m is stretched from the origin O. Now there is also a restoring force acting on the mass m. So this restoring force is proportional to displacement. So restoring force is proportional to displacement. It means F is equal to minus kx. K is spring constant. If we plug F is equal to ma is equal to m d2s by dt2, we will get a differential equation, d2s by dt2 plus k by m s. And if we assume omega is equal to root k by n, then we can simplify this differential equation into this form, d2s by dt2 plus omega s is equal to 0. And the solution of this function, this differential equation, is s is equal to a sine omega t plus phi. This is the solution of this differential equation, and here s is harmonic or periodic function, and where time period is t is equal to 2 pi by omega, and here a is the maximum deviation from the origin O. So this is the a amplitude, and we can calculate the frequency f is equal to 2 pi by t, and phi is equal to initial phase. If phi is equal to 0, then s is equal to a sine omega t. If initial phase is 0, then s is equal to a sine omega t. Now y is equal to a sine omega x plus phi. Now assume that a is equal to 1, omega is equal to 1, and initial phase is 0. Then this equation will become y is equal to sine x, and we can plot the sine graph for this function. It is the simple sine graph, where after 2 pi time period, this function will repeat itself. And if a is 1, omega is 1, but initial phase is pi by 2, then this equation will become y is equal to cos x, and the graph of this function is cosine x. Again this function will repeat after 2 pi time interval, And again, if y is equal to sine omega x and omega is 3, then y is equal to sine 3x, and there is a compression of this sine graph where after 2 pi by 3 time period this function will repeat itself. So these are the example of harmonic function or periodic function where we can plug any value of omega and we will get equivalent graph of that function or harmonic function.